Look at an elephant for a second. The trunk, the tusks, the sheer size. It feels like this was always where evolution was headed. But what if that feeling is wrong? What if elephants almost failed, again and again, before they ever succeeded? What if this story doesn't begin with giants at all, but with something so small you wouldn't notice it stepping over your foot? 66 million years ago, the dinosaurs were gone, and the world was quiet in a way it hadn't been for ages. In that silence, a very different story began, with Erytherium, a tiny, rabbit-sized hoofed mammal. No trunk, no tusks, no power. If you had seen it, you wouldn't have thought future ruler of ecosystems. You would have thought background noise. And this raises our first question: how small can a giant begin? Erytherium was barely 5 kilograms, small enough to be overlooked. It survived not by strength, but by being ignored. And that kind of survival raised a problem. Because in a world reshaped by extinction, one question decides everything. Where and how do you live? As ecosystems rebuilt across the early Paleocene, one solution seemed obvious: follow the water, swamps, river systems, and shallow coastal plains. Here, evolution experimented, producing Megafauna. It looked more like a small hippo than an elephant. Taper-sized, no trunk yet, only a flexible upper lip. Its fossilized teeth still carry chemical signatures of freshwater plants. For a moment, it looked like elephants might become aquatic. So why didn't this become another whale-type return to the ocean story? Because Megafauna fit its world too perfectly, and that was the problem. It became too specialized, committed, and fragile. This wasn't a path that led to size, reach, or control of land. It was evolution trying something, and quietly stepping back. Because while one branch leaned into water, another made a far riskier choice. It left the wetlands behind. Now everything changed. Megafauna stepped fully onto land, with longer legs, a more upright posture, and a face that began to behave differently. The nose and lip didn't just breathe anymore. They interacted. Tusks pushed forward, the jaw elongated. The face became a tool. So pause for a second and ask yourself, what happens when an animal starts using its face to control the world around it? Control replaced force. Flexibility compensated for size. Megafauna wasn't massive, roughly 2.5 meters tall at the shoulder, but its evolving trunk allowed it to reach, pull, and manipulate food in ways larger animals couldn't. Here, elephants stopped reacting to their environment and started manipulating it. And once that happened, evolution asked its next question: how far could this body plan go? The answer exploded with one of the largest evolutionary experiments elephants ever ran: the gomphotheres. Not a single species, but an entire family. 4 tusks, different trunks, different sizes, bodies built for forests, marshes, open grasslands, spread across continents. What followed was adaptive radiation, not refinement, but diversification. Evolution wasn't perfecting the elephant. It was stress testing the idea. Gomphotheres produced some of the strangest designs elephants ever wore. 4-tusked Rhynchotherium with downward curved lower tusks. Shovel tuskers like a Megalodon and Nathabelodon, built for highly specific ways of feeding. At first it looked unstoppable, almost excessive. But the more these tools specialized, the more survival depended on a narrow set of conditions staying the same. And the conditions didn't. As the Miocene climate grew less stable, shrinking habitats reduced feeding grounds. Specialized diets reduced flexibility. And then a new pressure entered the system. In the Americas, we find clear evidence that early humans actively hunted gomphotheres, butchered bones, kill sites, repeated encounters. Not everywhere, not all at once, but enough to matter. One experiment can survive change. Too many pushed too far cannot. And one gomphothere lineage would take specialization to its extreme. Meet Platybelodon. Its tusks flattened into a shovel for one precise job. It used its mouth like a tool, scooping vegetation from riverbanks and stripping plants with efficiency no other elephant had. It worked beautifully, too beautifully, because this design only functioned in one kind of a world. When wetlands shrank, that perfect tool became a liability. Platybelodon disappeared because it was locked in. When survival depends on a single tool, flexibility dies, and evolution takes note. This was the turning point, unfolding slowly between 8 and 4 million years ago. The noise faded, bodies stabilized. 4 tusks became 2, and the wild experimentation slowed. Gradually, the elephant blueprint began to look familiar. By the time this long transition ran its course, the resemblance was unmistakable. A more refined form had appeared, Stegodon. Across Asia, Stegodon appeared in different regional forms, yet the underlying design remained unchanged. One feature of that design stood out immediately: the tusks. They lengthened and closed in so tightly that the animal may have had to rest its trunk over them. It wasn't a prototype anymore. This was an elephant in everything but name. And just as the experiment finally worked, a new threat emerged. One that wouldn't favor the biggest, only the smartest.